Okay, this video is over 7.7 solving right triangles. What you're going to do is you're going to set up your trig ratios. You're going to solve for x, y, z or unknown values. And then you're going to give the approximate values to find them, meaning you're going to have to do trig on your calculator. So this first triangle that we have here, we have 16.9, we have x, and I'm going to say this angle here is 23 degrees. Okay, so in order to find this x value based on this 23 degrees, we have to know that based on this 23 degrees that this is opposite. So based on this angle here in yellow, at 23 degrees, we have, let's go, based on yellow, this is opposite, and this is adjacent. Now, based on opposite and adjacent, we have, there we go, SOHCAHTOA, which up here is the quick acronym for it. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So we have opposite adjacent, so we're going to use tangent. So in order to solve for this first one, we have tangent of 23 equals x over 16.9. Cross multiply. You have 16.9 times tangent of 23 equals x. Plugging that in my calculator. So it's a TI-84, but just doing the same thing. Buttons usually are the same. Same location, sine, cosine, tangent. The inverses are up above them. But what we're going to do is we're going to go 16.9 tangent 23 parenthesis enter. So approximately that measurement that I am missing, digital screen, let me turn the brightness down, there we go, 7.17. So I'm going to go to the nearest hundredth. So this length right here is 7.17, approximately. Now, to find my hypotenuse or my other angle, if I was solving the triangles, this angle I would take 90 minus 23 and get 67. So this length here is just 67 degrees. Okay. To find this angle up, or this side length up here, the hypotenuse, to find h, based on 23, this is adjacent, this is hypotenuse, so I would use cosine. So I would go cosine of 23 equals 16.9 over h, cross multiply, h times cosine 23 equals 16.9, divided out, hypotenuse equals 16.9 divided by cosine of 23, which, plugging that in my calculator, approximates out to be, try to get out of the reflection of my light, so 16.9 divided by cosine of 23 gives me 18.36. So this is 18.36. So that would be all my missing side lengths. So coming over here to this triangle, I have no unknown angles and I have a missing side. This missing side, what I would do is I would go and do the Pythagorean theorem. So this length here, I would go 7 squared plus x squared equals 13 squared. 49 plus x squared equals 169 minus 49 x squared equals excuse me, 120. Take square roots. X is equal to the square root of 120. So a nice number that goes in there is 4 and 30. So this would be equal to 2 square roots of 30, or approximately 10.95. You can do that because it says approximate when we are solving right triangles. Unless we ask you to do exact answers, you may approximate because you could use trig. Now, I have 2 missing angles. I'm going to use some colors here. I'm going to use orange on this one. I'm going to use pink on this one. So based on this, what I would do is I'm going to look at, let's see if I can get my camera here a little bit closer. What I'm going to do is I'm going to look at doing the inverse. So now, based on my orange, this is adjacent, and this is hypotenuse. Based on the pink angle, this would be opposite, and this would be hypotenuse. So I could either use sine or cosine. I just need to find one of the angles, because using the sum of the triangle sum theorem or the correlated triangle sum theorem, the orange and the pink angles add up to be 90, and they're complementary, so I just need to find one. So what I would do is I'm going to say I want to use sine first. So what I'm going to do is I'm going to put this as angle A. So I would go sine of angle A equals 7 over 13. So in order to do this and undo the function of sine, we have to take the inverse of sine. To do the inverse of sine, to find the angle measurement, we're going to use on our calculator this button here of sine, but we're going to use second to get to sine inverse. In order to get to the inverse, what we do is we take the trig ratio of the hypotenuse to, or the opposite side to the hypotenuse, adjacent to the hypotenuse, or opposite to adjacent, and when we say which way we're setting up our ratio, we will find the value degree based on that trig ratio. So you really need to make sure that you're clear about how to find the inverses or which setup you're doing. So like I said, I'm doing sine. So in order to solve this problem here, I would go sine -1 of my inverse equals A. So on my calculator, I would go second sine, get sine to the inverse, and then I would go 7 divided by 13, parenthesis, enter. So that approximation comes out to be roughly 32.58 degrees. So measure of angle A is approximately 32.58 degrees. To find the orange angle, which I'll call B, B would be approximately 90 minus 32.58, so 90 minus 32.58, which is 57.42 degrees. Now, I could have done cosine inverse. So if I did cosine inverse of this relationship, because adjacent hypotenuse, so if I go second cosine, 7 divided by 13, I get roughly 57.42. So it's your choice if you want to do both. You don't have to. You can just do triangle sum theorem. So what I have here is I have 6 questions from your notes. I'm just going to go through and I'm going to solve each triangle. I'm going to try my best to color coordinate. So if this is 65 degrees, this angle here would be 90 minus 65, which would be 25. Okay, so that's just a quick answer, done. Angle in is 25 degrees. No trig inverse. to find one of these two sides. So this would be leg. And I'll do this as hypotenuse. So if I want to find the hypotenuse based on the 10 and the 65, because I like to use what was given to me, based on the 65, this would be adjacent. This would be hypotenuse, so that would be cosine. So cosine of 65 degrees is equal to 10 over the hypotenuse. Cross multiply hypotenuse times cosine of 65 is equal to 10. Try that again. Hypotenuse equals 10 divided by cosine of 65. So the hypotenuse is approximately, so I'm going to take 10 divided by cosine of 65, which is approximately 23.66. Okay, 23.66. Now, that does make sense because this is 10 and 23.66, so I could use trig to find this leg, or I could use Pythagorean theorem. I'm just going to use some trig. So with the leg, this is adjacent, this is opposite, so I would be using tangent. So tangent of 65 is equal to the leg over, or opposite. I guess I could use the word opposite. It doesn't matter. Opposite to adjacent, which is 10. So leg is equal to 10 times the tangent of 65, which is approximately 21.45. And so because the measurements work out 21.45, I could do a quick check. Excuse me. So 10 squared plus 21.45 squared is equal to 560, and roughly that 23.66, now I've rounded everything, squared equals 560. So because I rounded, things are going to be slightly off, but those are really close, and so it doesn't matter. My two links would be the 21.45 and 23.66. So here on number 2, this is a Pythagorean triple. 3 times 3, 4 times 3, so this would be 5 times 3, so this would be 15. If not, do Pythagorean theorem. 3 times 3, 4 times 3, so that would be 5 times 3. Or do the Pythagorean theorem. 9 squared plus 12 squared equals hypotenuse squared. So 81 plus 144 equals hypotenuse squared. 256 equals 250. No, let's try that one again. 225. 225 equals hypotenuse squared. Square root both sides, and I would get 15 equals hypotenuse. Okay. So now once again, either A or C. So angle C I'm going to do in orange. Angle A I'm going to do in, let's do that one in purple. No. Yeah, let's do that one in purple. So, based on angle A, this would be opposite. This would be adjacent. So based on that, to find angle A, tangent of A is equal to 9 over 12. To undo this angle here being taken by the function of tangent, I'm going to undo that by doing the tangent inverse. So tangent -1 inverse. 9 divided by 12 is equal to angle A. Angle A is approximately so once again, move this just a little bit. To get that inverse, you go second tangent on TIs, hit enter, and it's roughly 36.87. I could take, to find pink, 90, or excuse me, orange, take 90 minus 36.87. So angle C is approximately 53.13. But I'm going to do it also by inverse so you can see that. So based on the orange, this would be opposite. And this would be adjacent. So with that, I'm still going to do tangent of C is equal to 12 over 9. To undo the function of tangent, I'm going to take the inverse. So C is equal to tangent inverse of 12 divided by 9. So second tangent, 12 divided by 9, and my calculator, roughly you can see comes out to be 53.13. So either way, you'll still get your same answer, but it's up to you if you want to do trig twice or if you just want to do it once and then just subtract it by its complement or find the complement to that of the 90. So I'm going to do that here again. And in order to find HJ, this would be Pythagorean theorem. So to find this length here, Pythagorean theorem. But I'm going to run through the inverses again. So to find angle G, based on angle G, I am given hypotenuse and adjacent. So this is hypotenuse and adjacent. So that would be cosine of G is equal to adjacent over hypotenuse, 14 over 16. To undo that angle, I'm going to take the inverse, so G is equal to cosine of -1 of 14 divided by 16. Once again, to find the cosine inverse, you're going to go second cosine, and then I'm going to take, I want to say it was 14. 14 divided by 16, and hit enter. So that comes out to be 28.96 degrees. So G is approximately 28.96 degrees. If you wanted to do J, this would be opposite and hypotenuse still. So this is still the hypotenuse. So it would be cosine, excuse me, it would be sine of J is equal to 14 over 16. So the inverse, so J is equal to sine -1 of 14 over 16. So in my calculator, second sine 14 divided by 16 inverse, I get 61.04. So approximately 61.04, and if I add those two together, I would get 90 degrees. Once again, I'm not going to solve for HJ, but you would do Pythagorean theorem. If you do that on your own, that would be approximately 7.75, or if you did it by exact answer, your exact answer would be It's the square root of 60. So that would be 4 and 15, so 2 root 15. So that would be your exact answer. But you can give the decimal answers with the trig problems. So going here to this one here. 43.6, angle A would be 90 minus 43.6. So this would be 46.4. So based on this, you could use either angle to find your unknowns. Based on the orange angle or the blue angle. Based on the 43.6, this would be opposite. This would be hypotenuse. So if I wanted to, I'm just going to do it based off B. To find opposite, you'd be looking at tangent and adjacent. So tangent of 43.6 is equal to opposite over 5.2. To find the hypotenuse, I would use adjacent and the hypotenuse. So cosine of 43.6 would be equal to 5.2 divided by the hypotenuse. Now to solve these problems, cross multiply, so opposite is equal to 5.2 tangent of 43.6, which is approximately going to be something. Cross multiply here. Hypotenuse times cosine of 43.6 is equal to 5.2. So the hypotenuse is equal to 5.2 divided by cosine of 43.6, which is approximately a value. So typing those in my calculator, 5.2 tangent 43.6. This is approximately 4.95, which is a reasonable answer. It's not bigger than 5.2, and it's opposite the smaller of these two angles. 5.2 divided by cosine of 43.6 is approximately 7.18. And that is bigger than the 5.2 and the 4.95, so that's a reasonable answer as well. So the other two questions that you have, which your guys' is all on a single sheet, are these two here. So quickly, if this is 57, 90 minus 57 would be 33. This is 29.9. To find this angle here, 90 minus 29.9 is going to be 60.1. If you don't like this fraction here, you can make that 10.875 and do the math off that. So what you're going to do is you're going to just go through and calculate everything out. So based on this angle here of 57, I'm going to use the one that's given to me. This would be opposite. This is hypotenuse. This is adjacent. So to find the adjacent and the hypotenuse, given the opposite, I want tangent of 57 to equal opposite over adjacent, which is 15 over adjacent. To find the hypotenuse, opposite and hypotenuse, that would be sine of 57 equals 15 over hypotenuse. In this case, both these problems, for what I use to set up, I would have to cross multiply and then divide. On this one here, this is the hypotenuse. So I'm going to use sine and cosine. I'm going to do it based off the 29 degrees. So based off the 29 degrees, this is opposite. This is adjacent. So cosine of 29.9 is equal to adjacent over 10.875. And then sine of 29.9 is equal to opposite over 10.875. Cross multiply, these ones aren't too bad. You'll get 10.875 times cosine of 29.9 is equal to adjacent, which is approximately an answer. Same thing on this one, you get 10.875 times sine of 29.9 equal to the opposite, which is approximately a value. So I have 10.875 cosine 29.9. This would be 9.43 based on rounding, and 10.875 sine of 29.9, approximately 5.42 on rounding. On this one over here, cross multiply and divide. So cross multiply, adjacent times tangent of 57 equals 15. Adjacent equals 15 divided by tangent of 57, which is approximately, should write that down below, is approximately, cross multiply again, hypotenuse times sine of 57 equals 15. Divide hypotenuse equals 15 divided by sine of 57, approximately. So this is approximately 9.74. And this is 17.89. So looking at that, 9.74 is opposite the 33. Smallest side, opposite smallest angle. 17.89 is the largest side, and that's opposite the 90 degree, which is great. And if we want to check it on the calculator, I can. So the biggest thing is you just need to make sure you take your time, know your sides. Always remember SOHCAHTOA is sine of an angle is equal to opposite over hypotenuse. Cosine of your angle of choice is equal to adjacent over hypotenuse. And last but not least, the tangent of your angle is equal to opposite over adjacent. It's all based on the angle of choice, so whatever angle you choose in a right triangle, that's what you label off of. So based off this angle, this would be opposite, adjacent, and the hypotenuse. Opposite is always across, adjacent is next to, that's the side that creates the angle with the hypotenuse.